Okay, so take your foldable and add to the very last flip the following factoring pattern. So you're going to have some two-term polynomials, and what you're going to notice is that they are not differences of squares. Sometimes they're going to be sums. The exponent should give you a clue that they are not differences of squares. For instance, you're going to see on the variables that they are to the third power. This would be the most easiest, not grammatically correct anyway. And we will discuss further some other exponents that would be perfect cubes. You'll also notice that your numbers are going to be perfectly cubed terms, and we will set up some of those numbers and dive deeply into what are some of those numbers so that you kind of have a cheat sheet. But here's how those factors are factor out. So here is what the problem would start out here in the blue. So we also have, there's two formats that they start out. You can have a sum of cubes, you can have a difference of cubes. And here's how they break down. You have two sets. You know how sometimes for MA we had two binomials. We have a binomial and a trinomial as two parts of the answer. So what you need to know is what are the three things, what number do I multiply, do I cube to get 8, and that would be 2. And then of course, what is the variable that I multiply out 3 times to get x to the third? And that would be x. And the same thing for the second term, and that would be y times y times y. So that is your first binomial. We take these terms now, leaving behind the beginning problem, and use them for the rest of our factored answer. And we take 2x, and we are going to square this term. So 2x squared is the first term of the trinomial. So 2x times 2x is 4x squared. And then we are going to take these two terms from the binomial and multiply them together. So 2x times y. Don't think about the sign. And 2x times y is 2xy. And then we're going to take the second term and we're going to square it. So y times y. And that is this last term here. And this is the factored form of our difference of cubes here. And if we had a sum of cubes, these are two perfectly cubed terms, what number do I multiply by itself 3 times? So what times what is 27, and that would be 3. 3 times 3 is 9, times another 3 is 27. And then of course the variable that I have to multiply out 3 times to be w to the third, which is w. Same thing for the third or the second term here. I need v times v times v would be v to the third. Now leaving behind this original problem, here is the first binomial for my factored answer. So I'm going to take these two terms, and that is how I get my same 3 terms here. And we'll look at the similarities between difference of cubes and sum of cubes. So we take 3w and square it, I get 9w squared. We take these two terms, 3w and v, multiply them together, and I get 3vw. I just put these in alphabetical order. Then I'm going to take my second term, v, and square it, v squared, and get v squared. Now, the similarities between these two answers are the terms. So I need my what numbers I cubed for my binomial. I need to take the first term and square it. I need to take the two terms and multiply them together. And I need to take the second term and square it. So all of those terms, I get them the exact same way. The only differences are the signs. So my first binomial for my difference of squares, same sign, I subtract. In my sum of cubes, in the binomial, I have an addition. Okay, and then my signs in my trinomial for difference of cubes are adding. In my sum of cubes, I have subtracting, adding. So that is the only difference between the two answers, or the signs. And that is our two, or really one, newest factoring pattern is the cubed factoring patterns, and we have some difference of cubes. And the only thing we need to pay attention to are the signs. All right, and we have something called quadratic form that we will factor. So we will be using MA, and we will be putting everything into ax squared plus bx plus c form, but they will not be quadratic themselves. They may be to the 4th power, the 6th power, the 8th power, but we will be putting them in quadratic form. So we will spend a little time on that and all the other factoring patterns that you know previously.